Last lesson, last exercise. I saw most of you finished it. I could see your reports, so I could see that everything looked like it was working correct. Now the thing is, AFM for firewall management, it's not that complicated. It's rules. Accept this, deny, block that, and so forth. Network denial of service is even more interesting. Not only is this not that complicated to set up, you don't have to do anything to set it up. It's a great feature that's so easy to use, you don't have to do anything. What I like to focus on in this lesson is how it does what it does and dispel any concern about false positives that people may have about network DOS. And then we'll look a little bit inside the configuration utility if you want to do some specific things with it. So, what are the benefits? This is your sales slide, your one and only sales slide. All right, remember AFM has the rules and all that, policies, rules, we just created that. AFM also comes with layer 7 denial of service, comprehensive layer 234 denial of service. Gotta be careful with that one. It's built into hardware, that's good. We are faster than our competitors who charge for a separate appliance, separate contract. This is free. So not only are we faster than them, but we're free. This comes along with AFM. And this is all based on negative security. Everything that's network DOS is just based on negative security, all based on signatures, which we call vectors. So every different network DOS attack type is designed to cause a target to process a packet that it can't process. A malformed packet. Something wrong with the packet in hopes that if you flood the server with enough of them, the server gets confused, doesn't know what to do. So we have lots of these vectors, some of which run in hardware, which means they're blocked before the request really even starts going up the network stack. I like to say it just bounces right off the bottom of the BIG-IP. And then some that run in software. Don't ask me which are in which. There is a document on askf5.com that you can find if you really want to know every vector that runs in hardware, everyone that runs in software. The lower level DOS vectors like layer 2 and some layer 3 maybe are in hardware. Layer 4 is usually in software. And we have a lot of different attack options, sweeps, floods, and that same concept of automatic thresholding that we talked about with layer 7 DOS. We can set manual thresholds or let AFM determine the thresholds based on trends. The key here, just like layer 7 DOS we saw yesterday, this protection takes place before this even happens. So if things are being blocked by the AFM DOS protection, they never even really get examined for a rule, for firewall rules. So it's the first line of defense before firewall rules even take place. So I'd like you to have a little break and read the following paragraph here for me to yourself.
Spelling. What behind is trash.
It's not going any faster, it's the same speed. This is a real-world example of a network denial of service attack. That was just one paragraph that I got from the f5.com website. I didn't remove any words. I didn't reorder any words. All I did is I started adding a fake word here. fake word there. And you probably found that at first, when there was just a couple of fake words, you could actually keep reading. You could get past it. But at some point, there were too many fake words. There were so many fake words that you could no longer get around them, and you became overwhelmed, and you couldn't read. And this is the idea of how network denial of service attacks happen. We always have valid requests coming in, real words. There's always real words that come in. That's what happens all the time. Sometimes a real word comes in. For example, if I'm trying to send a request to my Exchange server in Seattle, the request is going to go through several routers. Who knows how many from here to Seattle? And it's possible, but by the time my request makes it to my target, somehow it's become malformed. It's not, the packet is no longer complete, and the target can't read this. So my first question to you is this: what will the target, in this case the BIG-IP, what will it do with this? What's it going to do with this? You guys are tech guys, you should know. If the target can't read this, it's malformed, what's it going to do with it?
Drop it.
It's going to discard it. It can't do anything with it. It's just going to drop it. Well, what about this poor guy? He's on his web browser waiting for a response. The target dropped his packet. What's going to happen with him? Say it again?
Keep loading.
It's just going to try it again. It's going to try it again. His browser's going to try it again for him. And more than likely, the next one will make it successfully. He'll never even really know anything went wrong the first time. The key there, though, is if he sent a malformed packet, the device discards it because it can't do anything with it. The problem is the device tried to read it. It tried to process it. It looked at it, made it go up some of the network stack before it realized, something's wrong with this. I don't know what to do with this. Well, likewise, there are also intentional malformed packets sent to devices. That happens all the time. Every device out there is under some sort of attack. It's regular. Well, what AFM does, when you have AFM provision, the network denial of service begins to keep track for every one of those vectors that I talked about, every DOS vector. It keeps track of how many of these bad packets it gets per second for each vector type. So those are two vectors: bad IP version, bad TCP checksum. So in the past hour, 5 hours, 20 hours, on average, it's received this many of each of those vector types. That's actually considered normal. That just happens. Nothing unusual about that. I can read still the real stuff. But then this guy gets all of his friends together and they start flooding it with so much bad words, so much mess, that most targets will get overwhelmed like you did and just can't even process all the good stuff anymore, and they get taken offline. What AFM does, though, is AFM says, oh my gosh, the number of bad packets of that vector type, the one vector type, has increased so much, we're under a DOS attack. We're now under DOS attack, and I am now going to start the DOS protection for that vector type. And from that point on, while we're under attack, all requests that reach the perimeter of the BIG-IP of that bad vector type, they're just immediately discarded. Boom, right off, kind of bounce right off the side. Does not come into the stack and start getting processed. All these thousands and thousands of requests don't get processed at all. They just get discarded. So again, what happens if somebody who's not malicious sends a request from their browser, and by the time it got to the BIG-IP, it was unintentionally malformed and look like a bad IP version packet? Well, it's going to be considered part of the attack. And it's going to be discarded. But it was going to be discarded anyway, because it was a bad packet. The difference is, the user's browser is not going to get a response, it's going to resubmit the response. More than likely the next one, it's going to resubmit the request, more than likely the next request will make it successfully, the user will never even know. What I tell people who might have a concern about false positives, what about that poor user? If that user, if CK, on his computer, is sending bad packet after bad packet after bad packet after bad packet, and we keep discarding it, that's no longer an accident. Either he's doing it intentionally or he's got a bot running on there. He's got something running. That's bottom line. So even if we don't drop it, all we're going to do is force the BIG-IP to try to process it when it's not going to be able to process it anyways because it's a bad packet. So we're not dropping anything that couldn't have been processed to begin with. That's to dispel the myth of any false positives that we have. All we're doing is we're dropping them before the device even tries to process them. And that will continue until AFM recognizes that the number of bad IP version packets has dropped again. Because most of these network attacks are fairly short-lived. They don't last very long. Within a minute, minute and a half or so. They might relaunch it again, but they're usually very short-lived. In the meantime, during an attack, BIG-IP not only can continue to process valid packets, it's going to do a better job of processing packets than it would if AFM wasn't provisioned. Because now it's not even trying to process all this malicious traffic. So that's how it works. That's pretty much it. Again, the next few slides I'm showing you only because I'm showing you. All you have to do is provision AFM and that all is already taking place. But if you want, you can go take a look. We have the DOS protection properties. On this page, the main thing you're going to do is specify the publisher if you want to see log entries. You want to see some logging. Or you want to send logging to your syslog servers or whatever. Also, if you're doing automatic thresholding, which we're not going to cover, here you can also start learning or relearning to get new thresholds. You can also set up whitelists for addresses that shouldn't be affected by this. But that's pretty much your general stuff on this screen here. Now I'm using, and by the way, notice I'm using an AFM address list for this. We have another page. This is the device configuration network security page. And this is where all of the thresholds are set for all of these vector types. At F5, we typically don't recommend that these aren't even modified, that these are changed, because these are set by pretty highly skilled engineers who know this industry well. But that being said, if we wanted to, we could. If you're using dynamic signatures, you can enable this. I haven't played with it a whole lot. It's kind of like the dynamic signatures we had in AFM. So I've got to get some exercises for this, demos to show you. But we're going to keep that disabled. But let's say I'm going to open up all of my IPv4 vectors, and these are all the different vector types. Bad IP version, actually let me go back here. There's actually about 15 or 20 down here. Don't concern yourself. Do not concern yourself. Let your partners know. They don't need to concern themselves with what this is. What is that? What is that? What does it mean? You will not find any help in our materials of what each one of those vectors is. The only way you might find it is if you go to Wikipedia and look them up, and maybe you can see examples of a packet that's been malformed that will be picked up by each one of these. So don't worry about what all these vectors are. But for example, if I go to bad IP version, over here I can now see my different vectors. My different thresholds. I just want to explain what these three thresholds are for you in case you want to explain to your customer or your partners. The first one says, if the number of bad packets per second goes up 1,000 packets per second more than what was considered normal a second ago, we're under attack. Or if the number of bad packets per second goes up 500% more than what was normal a second ago, we're under attack. Or if the number of bad packets per second goes to this level, a virtual threshold, then we're under attack. And all that needs to happen is any one of these three. Any one of these three thresholds are met, and we're now considered to be under attack for that vector type. Some of these have additional settings. Layer 4, typically layer 4 vectors have some additional options, bad actor detection, automatic thresholding, and so forth. You have to learn to play with this if you want to. But you're only going to see that for the layer 4 vectors. So if you enable the publisher, the log publisher, you can then go and look at the DOS event log, just like all of our other event logs. There is one fairly big difference between this log and some of the other logs. I'll show you in a second. First off, we can see some information about the attack, the type of attack that we're talking about here. Over on the right, we can see the destination, the virtual server in question, the type, and then the number of packets that were dropped. I'm going to go back just one slide here, because what happens here is we're going to get a log entry every second for every attack type we're under. We might be under multiple attacks at once. Right now, if I go to the right again, I'm under multiple attacks at the same time. I got this attack going on, this one, this one, this one. Lots of attacks going on. So I'm getting a log entry for every attack type every second, showing me that 69 bad packets were dropped for this one, and 68. What I'm getting at here is we're not seeing every single request. We're not seeing every single one of those 69 requests. We're just seeing grouped together. In this last second, we dropped 69 and so forth. In a real environment, a real big IP, the numbers are going to be much higher. If you're under a DOS attack, these will be much higher numbers per second. This is just what we can accomplish in our lab environment. So this particular attack, this land attack, I wonder how long it's been under attack, how long this has been going on. We also have the attack ID. So one attack in progress, you're going to see a different log entry every second for that same attack ID. So I can just copy that attack ID, filter by it, and now I can see how long this one attack has been in progress. Looks like quite a while. Each one of these is a different second. And how many packets have been dropped by AFM. So some interesting stuff there that we have. Then you have this other new, this is actually very new. This DOS overview is a very new feature. I just want to, what I'll call this for you is a snapshot of what's going on right now. If I go back here and look on this, okay, this is great. I can see that we have this this is a no L4 attack, but I also had several other attacks going on at the same time. That's a lot to try to filter through on here to see how many attacks are going on. That's what the DOS overview attack page is for. I can see all of the currently running attacks, of the attack types, what's going on, what kind of mitigations, what kind of traffic is being blocked, and so forth. There's a bit to get to know about this page. I don't know much more than I've shared with you because I've only viewed this about as much as you're viewing it now. What all you need to share is that this is a visibility page. This is more visibility than we used to give for DOS attacks. So it's actually really good visibility. We also have this page, another visibility page. This just came out a couple of releases ago. A lot of people were very pleased with this page. I like this page. I hate this page. Tough. Some things about it I really like, some things about it make me crazy. I like the visibility a lot. You can, change your time range. What am I looking at here? I can see all of this attack. These are all the attacks that are taking place. All the simultaneous attacks. You can mouse over any one of them. See that attack ID we were just looking at. Other information about the attack. You can scroll down and you can see all the attacks that have been taking place, some of which are ongoing, some of which have already completed. Now comes one of my first complaints about this page. There's a lot going on in that table, a lot of important information in that table. And I cannot expand those columns and make them wider. I've tried to make the page wider. I've tried to zoom the page down and see so I can see more, and it just makes the table smaller. We need to do some work on this table.
Export it.
Because
Export it.
I don't know if I don't think there's an export button. One of the only ways I can see stuff is to put my mouse over this or put my mouse over that, and then I can see more data. So that we need some improvement on. There's also these really interesting, what we call widgets over here, just like on the DOS page, the custom page that we could create. There's all these little widgets, and for each one of these, you can pop this open and see all the device IDs of sources, bot signatures. This is really kind of cool, but there's some issues with this too. You'll notice over here I have two scroll bars. I have this scroll bar right here. That's for this whole page. And then you got this little thing here. That's another little scroll bar. That's for this panel. And it's a little cumbersome trying to get to some of these widgets. Another thing is this is not always very intuitive. But if you open up one of these widgets, you see some interesting data, but it's very condensed. It's not very intuitive that you can use this thing right here and drag that whole panel over and make it wider and see more data. So you have to get to know this page a little bit. But there's one part of this page that always gets kind of a cool factor, and that's at the very bottom. At the very bottom, you have the countries. This is the source of all of the attacks. This, however, only shows the source of layer 4 attacks. Not layer 2 attacks, layer 3 attacks. Only layer 4 attacks. But still, it's pretty cool. We didn't used to have this kind of visibility at all a couple versions ago. So that is Network Denial of Service. As I said, we're not going to do this exercise. I absolutely thoroughly encourage you to do it when you have time. But I want to point out a couple things. So let's turn to that exercise together on page 57.